When we want to be able to determine the convergence or divergence of sequences and find the limits of convergent sequences, we need to know what is the definition of convergence and divergence. Well, we know that if it converges, that means that terms approach a limiting value. When it diverges, we know that it has no limit. So I have a few examples here that we can take a look at. First example here is our given sequence. We go to 1/2 to 1/4. 1 over 8, 1 over 16, all the way to 1 over 2 to the power of n. So if we take the limit as n approaches infinity of 1 over 2 to the power of n, well, that's going to give us the value of 0. And therefore, this is going to converge to 0. The next example, we have the sequence formula a subscript n, which is equal to 2n divided by n plus 1. So as we take the limit as n approaches infinity of this, we can multiply both the numerator and denominator by the highest power in the denominator, which would be n. So we have 1 over n times the denominator and 1 over n times the numerator. So we end up with 2 in the numerator and then 1 plus 1 over n in the denominator, and we're taking the limit as n approaches infinity. Well, 2 we're left with a constant, 1 we're left with a constant, and then 1 over infinity is going to give us 0. So 2 over 1 plus 0 is 2, so then we know that this sequence converges to the value of 2. Up in the top right, we're going to look at this example. So we have the sequence formula, a subscript n, which is equal to 3 plus negative 1 to the nth power. So every time we plug in a value of n, we end up getting this repeating sequence. And so this repeating sequence is telling us that we have 2 and then 4, 2 and then 4, and then 2 and 4. So because it keeps repeating, the limit doesn't exist. So the limit as n approaches infinity of that sequence formula diverges because the limit does not exist. And then for the last one here, we have the sequence formula, which is equal to 2 to the n divided by 2 to the n minus 1. So what we want to do is we're going to multiply the numerator and denominator by 1 over 2 to the nth power, and what we're left in the numerator is 1 divided by 1 minus 1 divided by 2 to the nth power. So we're going to take the limit as n approaches infinity, so we know 1 is a constant in the numerator and it's 1 minus 0, which gives us 1. So therefore we know that this is going to converge to 1.